Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening.
Good evening. I would like to read out the list of students who completed the assignment which I had posted on Monday. I was not well, so I was not able to make the classes on Monday and Tuesday. So Tuesday's class is what I'm trying to compensate today. And for Monday's class, all of you know that I had sent an assignment. But the response is like this. So students who submitted the, the work, the assignment which I had given for Monday's class. So these students are appreciated for abiding by the instructions given. Priyadarshini, Priya, Arnav, Ravya, Sudarshan, Shriya, Tirunesh, Srinivasan, Harshita, Balaharish, Manasa, Shabarigrish, Lakshita, Nivedita, and Nishita. Other students, I don't know why. You had sufficient time. Tuesday also I couldn't make the class. So you could have done it on Tuesday, Wednesday, and today's Thursday. Nobody's responded. The others have not nobody, sorry. The others have not responded. And you all know that quadratic equations is a part of term 2 portions. This we had already, the introduction to this chapter we already had, like before there was this bifurcation, term 1, term 2 itself, we had finished, we had not finished, but we already had taken up the introduction to this chapter, quadratic equations. Only then we realized that, we were announced that quadratic equations forms a part of term 2 portion. So we just stopped it. We did not complete the chapter. But we did understand, a good amount of the chapter. That is, we had the introduction, and then I think we were just about to start the word problems when we got to know that quadratic equations will be a part of term 2 portions. So we done quite a lot, except I remember, except the word problems on quadratic equations, the rest of it we had finished. Which is why I thought it's a good idea to post this paper, which, covers the chapter almost in full. You have one of every kind here. You have one question of every kind. So I thought that, so this paper will be a good revision. I had also shared the introduction, some screenshots where you had the introduction to this chapter regarding the discriminant and other stuff. I shared that, and I did not want you all to write that. So it was very clearly mentioned, read through the introduction and work out this test 2, the questions in test 2. Read the introduction. You can go back to the message. I did not want you to write, but some of us had even written the introduction part of quadratic equations along with test 2. Very good. But introduction, I just expected you to read, recall, and work the questions in this paper, which is called test 2. So I thought I should engage you correctly. It's easy to give a holiday, but I thought, I should engage you. So Monday from 7 to 8:45, you're supposed to have my class. So if I'm not able to make a class, I thought I should engage you effectively, which is why I posted this. So that also needs some planning, no? I need to think. I could have just let it go like that. So please adhere to the instructions given in the classroom. You're expected to follow. You cannot excuse yourself for not doing this assignment. All those students who have not done, I'm really disappointed. It shows your irresponsibility. All right, children. So I would just like to discuss the answers in brief to these questions so that I can even check if you had. So children who have completed the assignment will be really benefited because you will know if you had a doubt somewhere, you can get it clarified now. These questions were sent along with the answers, so you could have referred to the steps and recalled. But just in case you still have a doubt, you can get it clarified now. Keep your tuition notebook open where you worked all this. Recall whatever difficulties you faced while solving these questions and get those questions, get those doubts clarified now. Okay, so the first question, find the discriminant. Find the discriminant. So you're given a quadratic equation. There's a quadratic equation here. Or we have to find the discriminant of this quadratic equation. So we know that discriminant is represented by capital letter D, and it's given by the expression b square minus 4ac. But since we already have the letters A, B, and C in the quadratic equation given to us, let's just say D is equal to b square minus 4ac. We'll use capital letters because we already have small a, B, and C, and also D in the given quadratic equation. Just to differentiate, we'll use D is equal to capital B, b square minus 4ac, A, B, C in capital. D, discriminant is always capital D. Discriminant is always capital D. We say D is equal to b square minus 4ac like this, but we'll use capital letter A, B, C also. D is equal to b square minus 4ac. Now, what are the values of A, B, and C? The values of A, B, and C. Take away this x square. This is A. This is A. Take away this x. This is B. This is B. And all this is C. Discriminant is equal to b square minus 4ac. So we need to get the values of B, A, and C. B, A, and C. The coefficient of x square. The coefficient of x square is A. This is A. The coefficient of x. This is B. This is B. And the constant is C. This one is C. Along with the sign, children. Along with the sign. So D is equal to b square minus 4ac. When you work this, you get the value of the discriminant of the given quadratic equation. That's what we have substituted here. B square minus 4ac. And when you're squaring, we'll have to be careful. A square, B square, C square, D square. But it's not 256. It's not 256 A, B, C, D square. It's not this. So you can see the value of the discriminant there. 1156 A square, B square, C square, D square. This is the value of the discriminant. D is equal to 1156 A square, B square, C square, D square. Along with the sign, children. Along with the sign we have to take. This is B square minus 4ac. In one, we are given an equation and we have to solve for x. We are given an equation, we have to solve for x. So the first thing we have to do is to bring the equation to the standard form. So let's simplify the equation given. Let's simplify the equation given by opening up the bracket. So a into x squared is ax squared, a into 1 is a, x into a squared, x into 1. And then bring all the terms to one side. Bring all the terms to one side. Open up the bracket. Open up the bracket. Bracket and the LHS and the bracket and the RHS. Bring all the terms to one side. And this is how it looks like. This is how it looks like. Now, am I audible and clear, children? Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. So now what do we observe? We have 4 terms in the LHS. When you bring all the terms to one side, so in the left hand side, we have 4 terms. We have 1 x square term, 2 x terms and 1 constant. That means you can proceed by grouping. See, we have 1 x square term, 2 x terms and 1 constant. On opening the brackets in the left hand side and right hand side and bringing all the terms to one side, the left hand side, the terms look like this. There is 1 x square term. There is 1 x square term. 2 x terms we have. We have 2 x terms and 1 constant. There is 1 term without x or x square. So you can proceed by grouping. Grouping meaning group 1 x square term and 1 x term and 1 x term and the constant. X square term and x term and a constant. You can also try to group it like this. Let's see if this works. Let's group it like ax square minus x minus a square x plus a is equal to 0. Ax square minus x, yeah. So what's common? X is common. So ax minus 1 minus a common x, oh sorry, ax minus a common, ax minus into minus is plus 1 is equal to 0. So ax minus 1 into x minus a is equal to 0. We get the same thing. See, x minus a, ax minus 1 is equal to 0. So you group 1 x square term and 1 x term, x square term, x term, then 1 x and a constant. Group the x square term and an x term, then an x term and a constant. See, this is the x square term. This is the x square term, x. So we group these two. Then this is another x term and this is the constant. It does not have x or x square. So group these two. So on grouping, you find the factors x minus a and ax minus 1, x minus a and ax minus 1. On equating it to 0, you find the zeros. X is equal to a or x is equal to 1 by a. The third one is a word problem. We have to frame, there's some information given to us. We'll have to frame an equation. We'll have to frame an equation. See, frame an equation for the given information and write it out as a quadratic equation in X. So what is given? The perimeter of a right angle triangle is 70 units. The perimeter of a right angle triangle is 70 units and the hypotenuse is 29. Hypotenuse is 29 and the perimeter, the sum of all the sides, ABC, the sum of all the sides is 70. That means AB plus BC plus 29 is equal to 70. Perimeter is 70. Perimeter is 70. AB plus BC plus hypotenuse is 29. So AB plus BC plus hypotenuse 29 is equal to 70. So you get AB plus BC is equal to 70 minus 29, which is 41. AB plus BC is equal to 41. So, which means we need to construct an equation, frame an equation for the given information. So whenever it's a right triangle, the equation can be constructed using Pythagoras theorem. It's a right triangle. It's a right angle triangle. So you can construct the equation using Pythagoras theorem. Remember that. That is, you should use AB square plus BC square is equal to AC square. So now you can write AB is equal to 41 minus BC. 41 minus BC. Okay, I've asked you to create an equation next. So let's call somebody as X. So you can say AB is equal to, say, call someone as X. You can call anything as X. So supposing you call AB as X. Supposing you call AB as X. Children, the equation is constructed using Pythagoras theorem. Pythagoras theorem. This is the equation. Now call something as X. You can call AB as X. X plus BC is equal to 41. So you get BC is equal to 41 minus X. Or you can, okay, let's do this one first. So you get BC is equal to 41 minus X. So what is AB? X square. Plus what is BC? 41 minus X the whole square is equal to AC square, 29 square. So when you work this, you will get a quadratic equation in X. You can call anything as X, children. Let me just do this again. See here, we have a right triangle. Listen carefully, ABC. We call it ABC. You can call it PQR. Hypotenuse is 29. Hypotenuse is 29. Perimeter is 70. That means AB plus BC plus AC, which is 29, is equal to 70. So we have AB plus BC is equal to 41. Now we need to construct an equation in X. Whose X? Nothing is mentioned. So you can call, see, you cannot call AC as X because AC is 29. So you either call AB as X or BC as X, anyone as X. Now supposing you call AB as X, supposing AB is X. So X plus BC. So if you call AB as X, then you'll get BC in terms of X is equal to 41. So you get BC is equal to 41 minus X. So if you call of the three sides, one side is 29. The remaining two sides, one side is X. The other side is written in terms of X. BC is equal to 41 minus X. Now, how do you create the equation? Pythagoras theorem. AB square plus BC square is equal to AC square. So AB square, AB we've called X. So X square plus BC is 41 minus X square is equal to AC square, 29 square. So children, you see that this equation has only one unknown X. So you'll have to open up the bracket here. A minus B the whole square. So do all that and get the quadratic equation next. And when you solve it, you can find the value of X. You can also call BC as X. You can also call BC as X. Okay, so see here. This is perimeter, children. Perimeter is 70. And why we have written this? This is to get the equation. Pythagoras theorem is used to get the equation. Now AB plus BC is equal to 41. If BC is X, so AB plus, if you say let BC be X, so you get AB plus X is equal to 41. So you have AB is equal to 41 minus X. AB is equal to 41 minus X. So here to get the equation, AB is 41 minus X, the whole square, plus BC square, BC is X square is equal to AC, 29 square. So expand this using A minus B the whole square, A square minus 2AB plus B square. Expand this plus X square is equal to 29 square. When you work this, you will get a quadratic equation in X. So you can see here, perimeter. Anybody can be x, so I've called AB as x. So BC is equal to 41 minus x. You can call BC as x. If BC is x, then you will get AB is equal to 41 minus x. Anything as x, children. Now, why do we write Pythagoras theorem? To construct the equation. To construct the equation. So how do we expand this 41 minus x the whole square? A minus b the whole square. A minus b the whole square is a square minus 2ab plus b square. This is a square, 41 square, minus 2ab, minus 2 into 41 into x, plus b square. Is equal to 29 square, which is 841. So children, on simplifying, you get this divided by 2 throughout, and this is the required quadratic equation in x. So here you're not asked to solve. Otherwise, if you solve this equation, you'll get two values for x, and hence you can find the sides of the right triangle. You can find the unknown sides AB and BC of the right triangle. You know the hypotenuse is 29 centimeter. You do not know the length of the legs. You do not know the length of AB and BC. On solving this equation, you can find the values of AB and BC. You can find the lengths of AB and BC, but that's not asked. So you stop here with the equation. 1, 2, and 3, please ask me your doubts. Children, what is your doubt with question number 1, 2, or 3?
No doubts.
Are you able to recall discriminant, children? Discriminant?
Yes.
Yes.
Can somebody tell me the quadratic formula?
Ma'am, quadratic
Tell me the
formula
quadratic formula.
minus b plus or minus of root t divided by 2a.
So if it's a quadratic equation in x, so we say x is equal to. If it's a quadratic equation in x, we say x is equal to minus b plus or minus root d by 2a, where d is equal to
Discriminant b square minus 4ac.
b square minus
B
4.
square minus.
B square
4ac.
minus 4ac. Yeah. All right. Okay. Question number 4. Question number 4. So see here, the first one was about finding the discriminant. Second one, it looks, see, it may look difficult, but actually it's so easy. You just have to open the bracket, bring all the terms to one side and group. 4 terms we had, and we just had to group. Third one is a word problem. Okay, let's see the fourth one now. Again, solve for x. Solve for x. So you can see that the powers are fractions, 2 by 3, 1 by 3. You need to convert this one to a quadratic equation and some other variable. In question number 4, we have an equation in x. In question number 4, we have an equation in x. We have to convert that equation to a quadratic equation and some other variable, not x, because it's already an equation in x. We need to replace x with some other variable. We need to reconstruct this equation as a quadratic equation in, say, y. As a quadratic equation in y. For which we have x to the power 1 by 3. When you square this, we get x to the power 2 by 3. So the square of x to the power, because how does that work? X to the power 1 by 3, the whole square. We multiply the powers, right? 1 by 3 into 2. So x to the power 2 by 3. X to the power 1 by 3, the whole square, is equal to, multiply the powers. Like when you have x square, the whole power 4. It's x to the power 2 into 4. Multiply the powers, x to the power 8. Similarly, here multiply the powers, x to the power 1 by 3 into 2, which is x to the power 1 into 2 is 2 by 3. So the square of this, the square of x to the power 1 by 3 is x to the power 2 by 3. X to the power 1 by 3, the whole square is x to the power 2 by 3. So this is nothing but 2 into x to the power 1 by 3, the whole square, minus x to the power 1 by 3 is equal to 28. X to the power 2 by 3 is written as x to the power 2 by 3 is written as x to the power 1 by 3, the whole square. We're writing it in terms of x to the power 1 by 3. X to the power 2 by 3 is x to the power 1 by 3, the whole square. Now we'll say let x to the power 1 by 3 be equal to y or any other letter other than x. So 2 into x to the power 1 by 3 is y. This is y. So y. This one is y. And the square minus this one is y. X to the power 1 by 3 is y is equal to 28. So see, 2y squared minus y minus 28 is equal to 0 is the required quadratic equation in y. And on solving this, you will get two values for y and hence find the values of x. So on solving, we get y is equal to 4 or on solving we get y is equal to 4. See, we got this equation, and on splitting the middle term, you can also use a quadratic formula, whatever. You can, to solve this quadratic equation, you can also use a quadratic formula. It's not that now you know the quadratic formula also. To solve a quadratic equation, you can split the middle term or use the quadratic formula. Completing the square is eliminated from your syllabus, so I'm not talking about that. You can also solve by completing the square otherwise. When you have to solve a quadratic equation, you can do so by splitting the middle term or by using the quadratic formula. So here we have a quadratic equation. We need to solve this. Here we have solved it by splitting the middle term. You can also use the quadratic formula and get these two values, 4 and minus 7 by 2. Okay, so here by splitting the middle term, we find that y is 4 or y is equal to minus 7 by 2. But whose y? Y is x to the power 1 by 3. Y is equal to, because here y is x to the power 1 by 3. So if y is equal to 4, the y is x to the power 1 by 3. If y is 4, that means x to the power 1 by 3 is 4. If y is minus 7 by 2, it means x to the power 1 by 3 is minus 7 by 2. So how do we extract the value of x? How do you get rid of 1 by 3? Cube it on both the sides. Because x to the power 1 by 3, if you raise it to the power 3, 3 and 3 will get cancelled and you can find the value of x. Why do we cube on both the sides? Because we need to find the value of x. X is raised to the power 1 by 3. You should get rid of 1 by 3. How will you get rid of 1 by 3? By cubing on both the sides. Because x to the power 1 by 3, when you cube it, you should not square. If you square, you cannot get rid of 1 by 3. When you cube on both the sides, you can x to the power 1 by 3. When you raise it to the power 3, 3 and 3 will get cancelled. So you can get the value of x. If it is x to the power 1 by 4, you should raise it to the power 4 on both the sides. Only then 4 will get cancelled and you can get the value of x. If it is x to the power 1 by 1 by 2, raise it to the power 2, square on both the sides. to get the value of x. So we have x to the power 1 by 3 is equal to 4. X to the power 1 by 3 is equal to minus 7 by 2. So we cube on both the sides. Because when you cube on both the sides, x to the power 1 by 3 will be raised to the power 3. 3 and 3 will get cancelled. 3 and 3 will get cancelled. So you get x is equal to 64. 4 cubed is 64. Here also 3 and 3 will get cancelled. So you get x is equal to minus 7 by 2 the whole cubed. So minus 3 times. So you will have the minus 7 cubed is 343. 2 cubed is 8. So the two values of x is equal to 64 or x is equal to minus 343 by 8. So we should assume this to be y. So this is y square. If this is y, this is y square. So you get the quadratic equation y. Solve and find the two values of y. Y means x to the power 1 by 3. But you should find the value of x. The given quadratic equation is the given equation is in x. You should find the values of x. Solve for x. You should find the values of x. You got the values for y. That means you got the values for x to the power 1 by 3. Cube on both the sides to get the values of x. When you raise this to the power 3, 3 and 3 will get cancelled. So x is equal to 4 cubed 64. Here again 3 will get cancelled because x to the power 1 by 3 into 3 it is. 3 will get cancelled. So here x is equal to minus 7 by 2 the whole cube. Minus 7 by 2 into minus 7 by 2 into minus 7 by 2. Minus 343 by 8. I'll ignore the fifth one. Completing the square is eliminated from the syllabus. Sixth one, solve using quadratic formula. You're aware of that? Using the quadratic formula. So this is a. The coefficient of x square is a. The coefficient of x is b. And the constant is c. This is a. X square. Remove x square. Whatever you see is a. Take away x. This is b. And this is c. This is c. So after finding the values of a, b, c, find the discriminant. B square minus 4ac. It's 196. X is equal to minus b plus or minus root d by 2a. Root 196 is 14. So you get these two values for x. 2 ones are 2 twos are. So 2 by root 3. 2 ones are 2 12s are. So minus 12 by root 3. Denominators are irrational. So you have to rationalize the denominators. So multiply and divide by root 3. The denominator is root 3. Irrational here also. So multiply and divide by, you're rationalizing the denominator. Why this step? Because you're rationalizing the denominator. In both the cases, the denominators are root 3. They are irrational. So rationalize the denominator by multiplying and dividing by root 3. So that's what we do here. On doing that, you get 2 root 3 by 3 minus 12 root 3 by 3. Am I audible, children?
Yes, ma'am.
Yeah. Minus 12 root 3 by 3. So again, cancels 3 ones are 3 fours are. So 2 root 3 by 3 or minus 4 root 3. So since the denominators are irrational, we rationalize. So these are the two values of x. in question number 7, if minus 4 is a root of the equation, if minus 4 is a root of the equation, so a root of, so when you're given the root of an equation, that value will satisfy the equation. Minus 4 is a root. We know that a quadratic equation can have a maximum of 2 roots. We know that a quadratic equation can have a maximum of 2 roots. One of the roots is given to you. Minus 4 is a root of the equation. A root will satisfy the equation. That is, in place of x, you can use minus 4. It will satisfy the equation. Minus 4 is a root of the equation, so which means it will satisfy the equation. So let's work that first. Okay, we'll not read the question ahead. If minus 4 is a root of the equation, minus 4 is a root of this equation. So what? So x square plus 2x plus 4p is equal to 0. Instead of x, use minus 4 plus 2 into minus 4 plus 4p is equal to 0. So 16 minus 8 plus 4p is equal to 0. 8 plus 4p is equal to 0. 4p is equal to minus 8. P is equal to minus 2. So we got the value of p. P is minus 2. P is minus 2. We have the same letter p here. When you see the question ahead, find k for which the equation given here is a perfect square. And see, we got the value of p. So here in this equation, we have the same letter p. You can use the value minus 2. That is why this information is given. This information is given to help you to find the value of p. Instead of x, use minus 4 because it's a root. So when you do that, you can get the value of p. And use that value here because in this equation, we have the same, it's the same question. You're not using the value of p from one question in another question. It's the same question. We got the value of p is minus 2. In the same question, the same letter is used in a different equation. So you can use its value, minus 2. So find k for which the equation given here is a perfect square. What's the condition for an equation to be a perfect square? Now, for example, is this equation a perfect square, children? This one is a perfect square. See, a 2x minus, this one is a quadratic equation. If you expand this is quadratic. 2x minus 5 the whole square is equal to 0. This is quadratic. Okay, we'll expand and you'll see it's quadratic. This is a perfect square. 2x minus 5 the whole square is equal to 0. This quadratic equation is a perfect square. Okay, let's expand this. So you get 4x square minus 20x plus 25 is equal to 0. Now we do not know. We're trying to find what is special about a quadratic equation that's a perfect square. We are trying to find what is special about a quadratic equation which is a perfect square. What if a quadratic equation is a perfect square? So D will tell us the speciality. Let's find the value of D. What is the value of D? B square minus 4AC, 4 into A into C. So D is equal to 400 minus 400. So D is 0. This is the speciality. If the quadratic equation is a perfect square, then the value of D will always be 0. You can try with any other quadratic equation that's a perfect square. See, we just took an example here. 2x minus 5, 2x minus 5, the whole square is equal to 0. 2x minus 5, the whole square is equal to 0. See, it's a quadratic equation. You can see it here. It's a quadratic. This is a quadratic equation that's a perfect square. This is a quadratic equation which is a perfect square. If the quadratic equation is a perfect square, then the value of d is 0. Now let's try something else like 3y minus 7, the whole square is equal to 0. Is this a perfect square, children? 3y minus 7 is 3y minus 7, the whole square. Is it a perfect square? Class, use the emoji, raise your hand. Yes, quickly, children. Shruti, Anish. Shruti, are you there? Anish. Ravya. Ravya. Are you there, Ravya? Shruti, Anish, Arnav, Priya, Harshita, Shabarikrish, Rakshan, Mutuvel, Akshay Ram, Shivani, Nafi, Balaharish, Manasa, Nishita, Sudarshan, Srinivasan and Thirunesh. Children, is 3y minus 7 the whole square a perfect square?
No, ma'am.
Why? Because 3 and 7 are odd numbers, huh?
No, ma'am. D is not equal to 0, ma'am.
Where d is not equal to 0? How did you find? Oh, you found d, is it?
Yes, ma'am.
Okay, fine. Children, is 25 a perfect square?
Yes, ma'am.
Yes.
Why? Because you can express it as a square of 5. Then why is 3y minus 7 the whole square not a perfect square? It's a square of 3y minus 7, right? The perfect square. Children, yes. 3y minus 7 the whole square is a perfect square. 3x minus 4y plus 5z the whole square is a perfect square. Is a perfect square. A plus b minus c minus d the whole square is a perfect square. It's a square of this expression. I don't know what I wrote. What did I write? 3y minus 7, huh? Okay. Why, Thirunesh? Now you forget finding the discriminant and not getting 0. Leave that aside. What makes you feel that 3y minus 7 the whole square is not a perfect square? It is a square of 3y minus 7, right? So it's a perfect square. 3y minus 7 into 3y minus 7. Why is it not a perfect square? Children, don't find D. Just by looking at the equation, tell me if it's a perfect square or not. Class, please think. Don't make me feel alone in the meeting.
Yes, ma'am.
Respond.
Yes,
Yes for what, children?
Yes, ma'am.
Yes for what? Please clarify. Yes for what?
3y minus 7 the whole square is a square.
It's
Perfect.
a perfect square. 3y minus 7 the whole square is a perfect square. This equation is a perfect square. It is a perfect square. Now let's find the value of d. Let us find the value of d. You have to expand. To find the value of d, we have to expand this. So we get a square, 9y square, minus 2ab. I think Tiranesh forgot minus 2ab. Minus 2ab, minus 2 into 3, 6 into 7, 42, minus 42y. Plus b square, plus b square, plus 49 is equal to 0. Now all of you find what is the value of a, children? What is the value of a?
9.
9. What's the value of? 1 second. What's the value of a? 9. What's the value of b?
Minus 42.
What's the value of c?
49.
Yeah, please find d, which is b square minus 4ac. All of you find d and tell me the answer. Please work. Please work b square minus 4ac and check if you're getting 0.
Ma'am, 1764, ma'am.
Not getting 0, is it?
Ma'am, getting 0, ma'am, by using calculation, ma'am. 1764 minus 1764, ma'am.
You gave me a shock. Because if it is not 0, I don't have an answer. Okay, Priya, right?
Yes, ma'am.
Okay, Priya, thank you. Yeah. Yes, Tirunesh. Where did you go wrong?
And instead of 9y square, I put 3y square.
Oh, okay. Okay. Yeah. Are we all getting 0, children? See, Priya's got 0. What about the others?
I got 9.
You got it? Yes, others?
Yes, ma'am. Got it, ma'am.
You got 0? So,
Yes, ma'am.
yeah, so you can try with any quadratic equation that's a perfect square. See, this is a quadratic equation. Can you see the y square term, y term, constant? It's a quadratic equation which is a perfect square. You write any quadratic equation, just write, you can write anything, children, that's a perfect square. So like minus 9, the whole square is equal to 0. See, this is the variable. Y is the variable. So for if a quadratic equation is a perfect square, then the value of d is 0. If it's given that if it is given that a quadratic equation is a perfect square, then the value of d is 0. If the quadratic equation is given to be a perfect square, it need not be a perfect square always. It need not be a perfect square. If it is a perfect square, then the value of d is 0. Okay, so we got the value. So from this information, we found the value of p. Now we need to find, they've not asked us to find p, but we found p. Some information is given. With the help of that, we were able to find p. So we've got the value of p and we are going to use that here. Instead of p, we'll replace the value we got. Now the question is find k, for which the equation, this one, is a perfect square. They're given that this is a perfect square. That means the value of D is 0. For this equation, the value of D is 0. That's all. This is the condition. This is the condition. D is 0 is the condition. D is equal to 0 is the condition. Substitute. So D is equal to 0 means B square minus 4AC is equal to 0. D is equal to 0 means B square minus 4AC is equal to 0. So substitute the values and find the value of K. Substitute the expressions and find the value of K. See the answer here. Okay, before that. Yeah. So this one is already in the standard form, children. See, it's like this, x square plus 1 plus 3k into px plus 7 into 3 plus 2k. So see, this is the value of A is 1. The value of A is 1. The value of B is, this is the value of B. Remove this x. This is the value of B. And this is the constant, which is C. The value of A is 1. The value of B is, this is the x term. See, this is the x square term. This is the x term. And this is the constant. This is the constant. See, it does not have x or x square in it. This is the x square term. This is the x term. And this is the constant. X square term, x term, constant. So the coefficient of x square is A. The coefficient of x square is A, 1. The coefficient of x is B. Remove this. All this is B. And this is C. So you can see here. Minus 4 is a root, so get the value of P, which is minus 2. And this one is given to be a perfect square. What I've done is I've taken the value of P. I've constructed the equation after using the value of P. P, right? P is minus 2. So this is the equation. This is the equation. We first find the value of P, apply the value of P in the next equation and get the equation. This is the equation. This is the equation. Now D is equal to 0 for a perfect square. If it's a perfect square, then D is equal to 0. That means B square minus 4AC is 0. B, what is B? The coefficient of X, minus 2 into 1 plus 3K. Minus 2, cover that, take away X, the rest of it is B. Minus 2 into 1 plus 3K, B square. Minus 4AC, 4 into A is 1, into C, 7 of 3 plus 2K. 4AC, this is B square, B square, B square. See, the whole of B is to be squared. The whole of B is to be squared. B square minus 4 into A into C is equal to 0. Minus 2 square is 4. 4 into 1 plus 3K the whole square. Minus 28 into 3 plus 2K is equal to 0. There are two terms. There are two terms. One is this one. The other is this. You can see that 4 is common. 4 is common. So divide by 4 throughout. So that will give you 1 plus 3K the whole square. And when you divide this one by 4, you'll get 7 here. So minus 7 into 3 plus 2k is equal to 0. 0 also by 4. You should divide 0 also by 4. That in the LHS there are 2 terms. Here there are 2 terms. Divide by 4. This one also by 4. The RH is also by 4. Dividing by 4 throughout. 1 second, children. Yeah, children. Sorry. I was telling you, yeah, this is one term. This is another term, and this is what we have in the LHS, RHS. So we divide by 4 throughout. We divide by 4 throughout. So here 1 plus 3k the whole square minus 28 by 4 is 7. 3 plus 2k is equal to 0 by 4, which is 0. And then expand this a plus b the whole square. A square 2ab b square multiply here is equal to 0. Then you get a quadratic equation in k. You can split the middle term or use the quadratic formula. It's not that you have to split the middle term. You can also use a quadratic formula. You must say k is equal to minus b plus or minus root d by 2a. Because you're solving for k. Don't write x is equal to. You're solving for k. So k is equal to minus b plus or minus root d by 2a. Plus or minus root d by 2a. And find the two values of k. And hence find the values of k. Is that fine, children? Question again. So from one part of the equation, you can find the value of p. Using this, you can find the value of p. Use that value of p here. And reconstruct this equation after using the value of p. Now this one is given to be a perfect square. So that means the condition is d is equal to 0 or b square minus 4ac is equal to 0. So when you substitute the expressions for a, b and c and work, you will get a quadratic equation k. Solving that, you will get the values of k. So if a quadratic equation is a perfect square, that means the value of d is 0. If it's given that a quadratic equation is a perfect square, that means the value of d will be 0. I think I've spoken enough. Let me put you to work. We'll discuss these two in tomorrow's class. We'll discuss the remaining two in the next class tomorrow, children. How many of you are still to learn this chapter in school? How many of us are still to learn this chapter in school? All of us have learned, is it?
Yes, ma'am.
All of, okay, fine. All right. Try this question. An aeroplane left 50 minutes later than its scheduled time, and in order to reach the destination 1,500 kilometers away in time, it had to increase its speed by 250 kilometers per hour from its usual speed. Find its usual speed. Please write the question in your notebook. Try it. We'll discuss the answer. Since all of you have learned this chapter in school, you can just give it a shot. Children, get your classwork. Please write down this question. Try this, children. I'll just get back. So how do we start? Let the usual speed of the plane be.
X kilometer.
Yeah, let the usual speed. Let the usual speed be. We have to find its usual speed. Let the usual speed be x kilometers per hour. Okay, then what will be the new speed? Okay, this is the usual speed. What's the distance? See, the three quantities are this speed, distance, and time. Speed, distance, and time. Speed, distance, and time. Okay, so the speed, let's say, is x kilometers per hour. What's the distance?
1250 kilometers.
1250 kilometers. Now, using speed and distance, you can find the time, right? The time taken. What is time taken? Time taken is equal to time is speed is equal to distance by time. Time is equal to distance by speed. So time is distance by speed. 1250 divided by x hours. That is, if the distance of 1250 kilometers is to be covered at a speed of x kilometer per hour, then the plane will take 1250 by x hours. Let me just write it again. Let the usual speed of the plane be x kilometers per hour. The distance is 1250 kilometers. Now, if this is the speed and this is the distance, what is the time taken? The time taken is calculated by using this expression distance by speed. 1250 by x, so many hours. Because distance is 1250 and speed is x. This is the actual time taken. Because this is the distance will not change. The distance between the two places will not change. This is the speed is the quantity that changes. If the distance between two cities or two places is fixed, the distance is fixed. If the speed is x kilometer per hour, then this is the time taken. What is the new speed? New speed, it had to increase its speed because it started late. It had to increase its speed by 250 kilometers. So the new speed is x plus 250 kilometers. Sorry, x plus 250 kilometer per hour. The new speed. The plane started 50 minutes later. It starts late. 50 minutes later than the scheduled time. So it had to increase its speed so that it reaches the destination on time. Supposing the plane starts at 4 p.m. and reaches at 6 p.m. It started at 4:50. It starts 50 minutes late, but it wants to reach at 6 p.m. only. Though the plane starts 50 minutes later than the scheduled time, 4:50 p.m., it has to reach the destination on time at 6 p.m. For that, the plane has to increase its speed. And it increases the speed by 250 kilometers per hour. So the new speed is x plus 250. Usual speed is x plus 250. X plus 250 kilometers per hour is the new speed. The distance is the same. Distance is the same, 1250 kilometers. So what's the new time taken? The new time taken is again distance by speed. Distance is this one by x plus 250. Distance is 1250 by speed x plus 250. Now, where is the time taken more? The difference in time taken is 50 minutes. The difference in time taken is 15 minutes. Obviously, the time taken here is less. Where the speed is more, the time taken is less. Where the speed is less, the time taken is more. Less speed, more time taken. Less speed. If your speed is less, you'll take more time. More speed, less time. Here you can see the speed x and x plus 250. X and x plus 250. Here the speed is less. X is less. X plus 250. The speed is more. So the speed is less. That means the time taken is more here. The speed here is less. So the time taken is more. Here the speed is more. X plus 250. The speed is more. So this time taken is less. So where it takes more time taken minus less time taken. That is a difference in time. Is 50 minutes. 50 minutes means 50 by 60 hours. This is very important. 50 by 60 hours. Because everywhere the unit is hour. Kilometers per hour. The difference in time taken is 50 minutes. The difference in time taken is 50 minutes. How do you find the difference in time taken? Here, like it takes more time here. It takes more time here. It takes less time here. The difference in these two time taken is 50 by 60 hours. So that's what I said. More time taken minus less time taken is equal to 50 by 60 hours. That's the equation. We need to solve that and find the value of x. Usual speed, distance, usual time taken. New speed, because it increases speed by 250 kilometers per hour. Distance is the same. This is the new time taken, distance by speed. Distance by speed, the new time taken. Difference in time taken is 50 minutes. So where it takes more time, where the speed is less. Here the speed is less, here the speed is less. The speed is more. Where the speed is less, the time taken is more here. The time taken is more. This is time taken. This is more. Here the speed is more. That means this time taken is less. This time taken is less. Here the speed is less when compared to this. The speed is less, so the time taken is more here. So this one will come first. That is the usual time taken comes first. Minus the new time taken is equal to 50 by 60 hours. How do we solve this? 1250 is common in the numerator, bring it out. And that gives you this in the bracket. LCM. I think you should work it and ask me your doubts. That will be better. Please complete this, children. Yes, children. I hope you all of you have finished working this.
Ma'am, 1 minute. Ma'am.
Yeah.
Completed.
Yeah. I just have to explain how this, how we simplify and get this equation. So I've taken 1250 common first. That's what you see here. After that LCM, x into x plus 250 is the LCM. So it will be x plus 250 minus x. X into x plus 250 is the LCM. So it will be x plus 250 minus x is equal to 5/6. Then x and minus x gets cancelled. And here x into x is x squared, x into 250 is 250x is equal to 5/6. Now you can get all the numbers to one side. So this 5/6, when it comes to the left hand side, it will become 6/5. And when you take this one to the other side, it will, well, like it's cross multiplying, no, it will go here. When you cross multiply, see, actually when this comes to the other side, it will be x squared plus 250x. When this one comes to the other side, it will be into x squared plus 250x. It will go up to the numerator. And this 5/6, it comes to the other side as 6/5. That's what you see. This one is taken to the RHS. So it comes here in the numerator, x squared plus 250x. Now this one is here. Okay, so this is gone. This is now here. This 5/6 is taken to the LHS. It becomes 6/5. It becomes 6/5. So this 1250, this 250, and this 5/6, which becomes 6/5. All numbers we have taken on one side. And this x squared plus 250x is on the other side here. And when you simplify this, you should get, when you work this one, you must get 3,75,000. When you simplify this, you get 3,75,000. And then when you take it to the other side, x squared plus 250x minus 3,75,000 is equal to 0. Quadratic equation next. And then you have the quadratic formula to help you find the values of x. One is negative, the other is positive. So the speed of the x is the x here represents the speed of the plane, which cannot be negative. So the usual speed of the plane is 500 kilometers per hour. Usual speed, find its usual speed. So this is the usual speed. This is the distance. Distance by time is distance by speed is the time taken. New speed, distance. So new time taken. Speed, distance, find the time taken. New time taken. This is the new time taken. The difference in time taken is 50 minutes. Where the time taken is more minus where the time taken is less. That difference is 50/60. Why 50/60? Because 50 minutes. It should be in hours. So 50/60. Everywhere the unit is kilometer per hour. But this is in minutes, 50 minutes. So convert it to hours. Where does it take more time? Where the speed is less. Where the speed is less, the time taken is more. So here the speed is less. See, when you compare the speeds x and x plus 250, when you compare these two speeds, x and x plus 250, X is less speed. X plus 250 is more speed. So here the speed is less. So this time taken is more. So first, more time taken minus less time taken is difference, no? So you should subtract, not add, is equal to 5/6. This is homework, children. Write down this question. We'll see the answer to this in tomorrow's class. Done, children?
No, ma'am.
Have you all taken down this question? Okay.
Completed.
Yeah. Yeah, this is your next question for the class today. The sum of the ages of father and son is 45 years. 5 years ago, the product of their ages was 124. Find their present ages. Okay, so what shall we assume here, children? Father's age or son's age?
Father's age.
Okay, so let the father's age be
X.
X. What is given? Father's age plus son's age is equal to 45, correct? If you call the father's age as x, x plus son's age is 45. What is the son's age then? 45 minus x. It's given that the father's age plus the son's age is 45. The sum of the ages of the father and son is 45 years. So if you say, let father's age be x years, x plus son is equal to 45. So son's age is equal to 45 minus x. So if father's present age is x, then son's present age is 45 minus x. 5 years ago, what was the father's age? What would have been the father's age 5 years ago? His present age minus 5. Yeah. And 5 years ago, what would have been the son's age? His present age minus 5. His present age, whatever is his present age, minus 5. That is 40 minus x years. 5 years ago, the product of their ages was 124. So that is father's age into son's age 5 years ago is equal to 124. Product of their ages is 124. So father's age 5 years ago into son's age 5 years ago. This is what it is. You can assume anybody's age is x, children. Anybody's age is x, father or son. Let me see how I have worked. Okay. You can take the help of this working to complete the answer. Okay. So from this we get the equation father's age into son's age 5 years ago is 124. On substituting, we found their ages 5 years ago. The product of these ages is equal to 124. So this is the quadratic equation you get. Again, you don't have to split the middle term, children. You can solve by completing the, you can use a quadratic formula. Please, you can use a quadratic formula. You don't have to split the middle term like this. You can use a quadratic formula. So x is equal to 36 or x is equal to 9. So when you take x is 9, supposing x is 9, what is x? The father's age. If you take x as 9, then the son's age will be 45 minus 9, 36 years, which is not possible. If you take the father's age as 9, then the son's age will be 45 minus 9, 36, which is not possible. So x is equal to 9 is not possible. So x is equal to 36. Father's present age is 36. X is equal to 9 is not possible. X is equal to 9 is not possible because then the son's age will be 36 years. So the father's age is 36. So x is 36. That is the father's present age is 36 years. And the son's present age is 45 minus 36, which is 9 years. Is it fine, children?
Yes.
Any questions here? We'll solve this in tomorrow's class, children. Just write down the question. You can think about it. A sailor can go 8 kilometers downstream and return to the original position in 1 hour 40 minutes. If the speed of the stream is 2 kilometers per hour, find the speed of the boat in still water. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. Children, those questions which we discussed from test 2, from the paper which was, from that paper test 2, all the questions are very important, children. From the examination point of view, I've picked one of that paper has one question of every kind. If you feel you have some doubts there, please feel free to get it clarified tomorrow. Do not ignore them. So go through the questions. You have the pictures on WhatsApp. Go through the questions and the answers. And make sure that it's very clear. If it is not, get your doubts clarified in tomorrow's session. All right, children. So that's it for today's class. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you.